So let's take a look at this example of a gas law here. In this case, I see I have a sample of gas. I got a volume, pressure, and I have temperature in degrees Celsius. They ask me what the new volume is. So if I have an initial volume and a final volume, I know I'm going to use the combined gas law. So as we look at it here, we need to get our units to match though, because they're new volumes in millimeters of mercury. That's different than the atmospheres. And then we have Kelvin. We always want to work in Kelvin. So we need to first convert Celsius to Kelvin, and then let's convert millimeters of mercury to atmospheres. So all the units on each side, they match up. So for Celsius to Kelvin, we add 273.15 to Celsius. We'll end up with 300.35 Kelvin. So we've converted that. And then for millimeters of mercury, so I could just divide this by 760. That would get me to atmospheres. And that works because we know that 1 atmosphere is equal to 760 millimeters of mercury. That's the conversion factor. So we multiply, and then we'll have millimeters of mercury cancel out. We're left with atmospheres. So 1580 atmospheres divided by 760, we get 2.08 atmospheres. So I'm just going to move this up here. Let's get rid of this. So at this point, everything's in the same units. I just plug everything in, and we're going to find that new volume, V2. That looks like this. So all that's left is to find V2, just to get this by itself in the equation. So we're going to find V2. Let's give ourselves a little room. I think I'll multiply both sides by this here. So this cancels out. Then I'll divide both sides by this 2.08 atmospheres. And this will cancel out, and we're left with V2 here. So now when I look at my units, I have Kelvin on the top and the bottom, atmospheres, and then atmospheres. Those units cancel out. We're left with liters. So we know we set it up correctly. So now we multiply everything on the top and then everything on the bottom, divide the numerator by the denominator, and we end up with V2, our final volume. That equals 8.6 liters. And since we have 2 significant digits here, that makes sense to have 2 here. So that's another example of using the combined gas law here to figure out the new volume, given all this information here. Do make sure that all of your units in the initial and the final conditions match up in degrees. That should be in Celsius. It's Dr. B. Thanks for watching.